All right, everyone, so today we have a algebra question related to distance and rates and times. So we have two people start pedaling in opposite directions from a common starting point. Find how long it takes them to be 20 miles apart if one person has a speed of 7 miles per hour and the other person has a speed of 8 miles per hour. All right, so let me start by naming a variable, call it t, and let t be the time it takes the cyclist to be 20 miles apart. And so let me also draw the scenario here. So let's say you have one person right here, the other person is right there. And they start with some common starting point. And one person goes this way and the other one goes that way. And each of these has a different speed. One has a speed of 7 miles per hour. And the other one's got a speed of 8 miles per hour. And the idea is I want to know when they're 20 miles apart. So the idea is like if you combine their distances, they would be 20 miles apart. And that fact leads us to an equation. So again, and if you need to pause this video and just think about that for a second of what I just said. So we want to use the fact that we're looking for the time that it takes for the two cyclists, two people, to be 20 miles apart. And what I'm saying is that the way that happens is that you add their distances. So the distance of person number one, so let me just call person number one the person that's going 7 miles per hour, plus the distance of person number two. Those two distances have to add up to 20 because we want to know when the distances apart from each other is 20. Okay, 20 miles. All right, well, how do I figure that out, or how do I get that variable t involved is more important here. So we have this very famous equation in these types of problems, which says that distance, d, equals rate times time, or d equals rt, or sometimes people call it dirt. R is your rate, and that basically means how fast you're going per usually it's an hour of time. So in this case, for person number one, their rate would be 7 miles per hour. So if you take 7 times t, this would be the distance they would ride in a particular amount of time. And here t is in hours because we have miles per hour. That's indicating what the time is in. You can certainly rephrase this question to say, I want to know how much it's in minutes per hour, or sorry, in miles per minute, etc., something like that. You could do that as well. However, I'm going to keep the time to be in hours. So once again, by default, whenever you're given the speed of something, the variable t will be in terms of the speed, the time measurement, so it's in hours. Okay, so then I'm going to do the same thing for person number two. 8t is the way I would describe the distance for the second person, because if they write 8 miles per hour times t hours, 8t is how much their distance is. Okay, so that put together gives me 20. Okay, so distance of person one plus distance of person two together gives me 20. And while we have like terms, you have 15t equals 20. And we're going to solve for t here by dividing by 15. And if you divided both of these fractions by 5, that comes out to be 4/3, or 1 1/3 hour. Okay. Usually it's preferable that you write times if you get like an improper fraction in terms of a mixed number, because it's kind of weird saying 4/3 hours. Nothing wrong with it mathematically, but rather say 1 1/3 hours. And the 1/3 of an hour, a third of an hour is 20 minutes. So this would be an hour and 20 minutes, okay, if you prefer that. And there you go. So that's how you use that equation d equals RT to solve equations about distance and such. One example at least. Hope this helps. Thank you for your time.